to talk about Go, Golang for PHP programmers. I have some talking points which I want to talk about. I don't know if I'm going to finish them all because I have no idea where this talk will end. Could be fine, could be a complete disaster, we don't know yet. If you have any questions, if there is something that you think about how does this work, how does that work, just ask. We can go basically everywhere. There is no fixed storyline in the whole talk. I literally make it up as I go, as I normally do. Works fine in development. Let's see if it works on this. Fake it till you make it. Okay, why Go? For me, because Go is awesome. I think that's the one and only reason why I do Go. Doesn't mean that PHP sucks or anything. It just means that it's another language in my toolbox. If you only know PHP or only know Python, everything you want to do will be done with PHP or with Python. If you have another language like Go or Rust or C or Java, at least you have an idea that if you have a problem, you can solve it maybe in another language that makes more sense, it's more efficient or easier to work with. So basically, that's what I want to teach you today, a little bit about Go, so you have at least an idea on the capabilities of Go. Doesn't mean you all can go home tonight and start working as a Go guru or anything, but at least it gives you some pointers and some steps to actually get going. Getting to Go is actually quite easy because it's for me, I hopefully for you too, a very simple language in a sense that it's not like a lot of symbols, a lot of different pointers to here, pointers to there. That doesn't make any sense unless you know anything about the language. So it's a very natural language. You know what is what, and there's only a few small catches which I will definitely talk about. So reading Go is actually quite easy once you get the hang of it. True for all languages, but I think it's easier to do in Go as well. So let's start. I'm actually using an IDE for this. It's Golang. So if you know PHP Storm, this is basically PHP Storm for Go. Pretty much the same way. You don't have to use an IDE. You can use it on a command line. Well, maybe easier sometimes. But this is just for me to show you how it works in an IDE. So what I'm going to do is I'm going to create our first Go file, and obviously the first thing we do that Golang does is something wrong. I'll get the text a bit. That's readable?
Yeah, no.
Okay. So when you create Go applications, you create packages, and there's one main package which is called main. Yes. So Go is easy, right? It's simple. And the main package has a function, has an entry point. So it's not like you're gonna go to a website of a web server. Go can actually create binaries, so it has to have an entry point. And the entry point is a function. Everything is a function, so there's no methods or function differences. Everything is a function, and that function is called main. That's it. And what are we going to do in main? We're going to print the string hello world. Hopefully this does not make any, you all know what this would probably do? I hope so. Otherwise we're going to have a very bad time. Now, so this is going to print literally hello world with a new line. Now there's a few things to notice. First of all, it's funct, it's not function. I don't know why. It probably saves you 4 keystrokes, so I think that's the main reason. But also one thing to notice is that there is no semicolon here. You can type them, I wouldn't advise them, because a lot of people think that Go does not need semicolons, but actually it does. What Go does is when it compiles your application, it's going to add the semicolons for you. So it needs it, it just put them there automatically. There's only a few instances where you have to tell it from, okay, so we have to do a semicolon here. That's basically where you have multiple expressions or statements in one line, which is something you don't do very often anyway. So sometimes you have to do it, but most of the time semicolons are taken care of you by you from Go itself. Now notice that if I put this bracket here, that it's gonna say I'm missing a function body. One of the reasons is that Go is very specific on formatting. So Go itself has a formatter. It's basically what PSR 12 is for PHP, but it's built in Go. That means that pretty much everybody uses the same format for their code. So it doesn't matter if it's my code or somebody else, or if it's old code or new code, it's all the same formatting. One thing that might be annoying is they use tabs instead of spaces, but it will take about 15 seconds to get over that, and then you won't notice it anymore. So you don't even, I don't even see it or care about it. That's the only thing that's really different from other things, other languages. So one thing they want is to have the bracket on the same line as the function definition. So, can we run it? Actually, we can. We press the play, we say build, each directory, let's see if this works. Oh, no, let's put it this way. We're going to say go, actually we say go run. I'm in the directory where that file is, that hello go file is. I'm going to say go run hello.go.
Can you please increase the font of the terminal?
I hope so. Better?
Yeah.
Okay, so I'm going to say go run hello.go, and it prints hello world. So this only runs it. You can also build it. And if you build it, then you actually have a binary called hello. And if you run that binary, it does the same thing. One thing about Go binaries, by definition, that's not always the case, but they are all statically linked. They don't need any other libraries. So what you can do very often is if you build your application into one single binary, then only that binary has to be moved to another server, like your production server or even your Docker environment. So you can actually use the most basic operating system, and sometimes you don't even need an operating system, so you can actually use the Scratch file of the Scratch Docker image, which is basically an empty Docker an empty directory with no files in it, and then you can run the same binary as well, so it doesn't need anything else, which is really cool. Another real cool thing is that even though this is, well, this is actually WSL, but it's basically Linux in Windows, I can say to Go, I want to build this for Windows, and I'm going to build that hello.go file. And if I look here, now I have an executable. So what it can do, it can compile to all kinds of different platforms on whatever platform you are. So if you are working on Linux, no, listen, if you are on Windows and you have a Linux production environment, doesn't matter. You can build it for Linux on your own system, and it's for Linux. If you have an ARM processor, CPU, you can build it for ARM. If you have OS X, you can build it for OS X. You can do all kinds of different build combinations on your own system. if you ever have done cross-compiling with, for instance, C, then you know how much of an issue that is to get it all up and running. In Go, it works literally out of the box. So I can actually say, I want it for OS X, and say go build hello.go, and I output to hello OS X. Oh, I have to do it afterwards. Hello.go. And if I look now, then I have an OS X file, and if I look at it, it says it's a 64-bit mag.o file, which is a...
Is Android included? Or? And like mobile devices?
I have to see if this is the correct one. No. Go dist. Go dist. No. There is a command that shows you all the platforms and all the CPUs, and you can combine them together. There's a lot of Android, but most likely it will be there, at least the CPU. So basically, this is hello world. I have to get rid of this. Hang on. Get rid of this. Okay. It's a package. Oh, sorry, it's a file. I have to set this up. Hopefully only once. I already changed my system for what we're going to do later on, so bear with me. This is not something you have to do daily. Okay, this my malware blocker actually blocks my Go binary for whatever reason. I think it's malware to print hello world. Took me a while to actually understand what's going on, but let me just... Okay, so now we have printed hello world. I don't know if you can see this, because I have no idea how to increase the font size of this view mode.
You can enable presentation mode.
You see there are much smarter people in the audience than I am. Only I have no idea how.
File,
Oh, enter presentation.
but that's probably only for the code.
Yeah.
But the other part.
Oh, yeah.
Nice.
Okay. So you got your Go certificate right now.
No, it's PHP song.
Yeah, no, it's the same. It's the same editor. So yeah. Okay, so let's continue with some of the basics. So we need variables in most languages. Not all of them, but this language does. Go is strict type. PHP wants to be strict type, but isn't. Go wants to be dynamic, but isn't. So Go is literally, you know, it's one or the other, but they're all like, yeah, I wish I was somebody else. But actually, Go makes you think about variables. And once defined, you cannot change them into something else. It has a few benefits, because when the compiler knows something is a string or something is an integer, it can actually do optimizations for that, something that PHP cannot do when it doesn't know if something is a string or int or boolean or array or whatever. So what you normally see is that you declare with var and you say s is a string. So I have declared s to be a string. Now I can assign something to s, for instance word, and this I can change into something like this. So print hello with the s as a string and a new line. See something different. So hello. Okay, so that works. One of the things is that if, for instance, if I change s to become 4, it will say No, you can't, because for is not a string, so you can only define strings because you have defined it as a string. However, you can do some kind of shortcut because you define a string here and then you're going to define the actual string to it. You can also say create a variable and assign something to it. So this is like the Turbo Pascal notation, notation. So this is declare and assign at the same time. So just the same thing, just print that. That means this doesn't work because now we declare s again. Even though it's a string, we declare it again, and code doesn't like that. Another thing is that if you actually don't use that string, Go is going to say, listen, you declared it, but you're not using it. So it doesn't compile if you're not using it. You literally must clean up after yourself. If you have variables that you don't use, they cannot be declared. Or if you assign it to something, you have to use them, otherwise it literally won't compile. Can be very annoying when you're debugging stuff, but in the end it has a lot of benefit because your code is much cleaner that way. So we can actually define an integer. Well, let's do 42 because sorry, too much PHP. One of the things is what PHP is very happy to do, but Go isn't, is something like this. Because what it does now, it wants to concatenate the string with an integer. It can't, because an integer is not a string. PHP is like, oh, listen, I will magically turn it into a string. Go is, no, I'm too lazy for that. You just do it yourself and then come back with me with a string. There are other methods to do this. For instance, you can actually say, I want to print it with printf. So you can say, hello, print a digit, and then actually add that digit to it. So this is pretty much the same thing as what you can also see in PHP with sprintf. It doesn't work because you actually need to import this from a package. Now, pretty much everything in Go is located in a package. There are a few functions that are outside packages. So you saw that print function. The print function is a built-in function, so that's not in the package. But printf is inside the package, in a formatting package. So that's the fmt. And then just like PHP, where you say use whatever, you're going to say use format in this case. Also the same thing, if you're not going to use it, then it's going to complain about s, it's going to complain about I, because I don't use it. And it already removed it for me. I don't want it for me to remove, but my Goland is too smart for this. Maybe if I add it again manually. So we have something like, no, it's too smart. Okay, but if it's there, then it just say, listen, you have an unused import, get rid of it. So in this case, Goland does it for me. And you see that it actually adds it if it's not there already. So let's do this. So we have the 42, print hello, and then it works.
Then the package is included in your binary? Or?
No, the packages are just literally source code found in your Go that you installed on your system, but it's going to get all the code that it needs. So in this case, for the format functionality, and it compiles that into your binary.
Yeah.
So ultimately, yeah, it's all in one binary. But there's a lot of packages by default that you can actually use. Yeah.
Do you need to declare the package in front of the function, or if you remove it, does it still work?
No, you always declare it at the top.
No, but I mean in front of printf. If you have it imported, can you remove?
Yeah. So what you can do is you can actually say, I want to import it in the current package, basically, and then it can work. Let me see. Oh, sorry. I think I looked for that. Yeah.
Okay.
So dot means imported in the current package, and then you can use it. To be honest, with things like format, you probably don't do that because this is more explicit.
Mm-hmm.
Go really likes explicit stuff, which I think is nice, but not everybody agrees. But not everybody is me. Okay, so that's basically.
When you import everything, how does it handle same functions?
It can't if you all import it into the same package, into the same main. But if you import format, then it's actually going to use FMT format as your separator. So this is basically package function. So if I have another function, so for instance I have a function called, I make this a string, and I have a
If you have another package with the same function.
yeah, if for instance string conf is now an extra package I did, if it's the same function, it would literally be this. So you have the string conf in front of it.
Okay. What? Okay.
Clear or not?
Yeah, I think he means when you import it as a package of name, as a part of
Oh,
name,
then it
you
will
will
complain.
override your function.
Then it will complain.
Okay, it will complain.
Yeah.
So it's simply not possible.
Yes, it's possible. But, for now, no, it's not
For now.
Don't want to know how much is possible with Go. It's really hard. Okay, so we have ints, we have strings, we have booleans. One thing, if you have to be explicit about integer sizes, which sometimes you have to do because you are on a 64-bit platform or you want to have an 8-bit integer, you can also specify that. So you can say, I have I, and that's an uint or an uint 8, an unsigned integer 8 or unsigned integer 16. You probably won't use that much because it's not something you are used in PHP as well. An integer is an integer basically, but they have different sizes in Go. So if you need that, then at least it's there. So for now, don't worry about it and just say int. That's fine unless you need something really specific. There are also arrays, but first I like to show you functions. We already questions?
No.
Okay. So let's create a simple function. We call it function hello, and that function gets arguments. So in this case, it gets a string called s. And what does it do? Well, we can say it's gonna return something. In this case, a string. So this is pretty much similar as PHP nowadays. What does it do? It returns hello plus s. And now what we can do is we can say hello moon, get rid of this, get rid of this, and then it will print literally.
You don't need to print that.
No, we don't need, we could use print or even print line. Doesn't really matter in this case. So we can return stuff, but one of the cool things is that we can return multiple variables at the same time. And one of the things you see very much is something like this. So it returns strings and an error. And what happens here, that for instance, if the string equals to moon, and notice that I don't use parentheses because you don't need them, I'm going to say return an empty string and return an error, a new error with cannot hello the moon. Otherwise it will return hello s, and it return nil. Nil is just null for Go. So you can, instead of an arrow, you can also return nil. So what I can do now is I can have that function. I'm going to say s is hello moon, but we actually have two arguments that I'm returning right now. So I can say hello and r from hello moon, and that's actually what's being returned. So if I have two variables returning from the function, I need two variables to collect them. If I don't want to use the s, but only want to know about the r, the error, I can actually use underscore. That's basically, don't do anything with it, but at least it's explicit that you know that something else has been returned there. But I'm going to use them both, and I'm going to say, well, print s. Now the only thing is, if there's an error, it doesn't do anything yet. But one of the things you see over and over and over again in Go is something like this. If r not equals to nil, log panic r, something like this. So when there is an error, it will, in this case, panic, which means dump a stack trace and exit the program. Normally you want to do it a little bit better, but it's just for demonstration. This is a very common thing in Go. So we have functions. Functions return values, but also return 9 out of 10 times an error. Once it returns an error, you will check that error. If you don't check it, there are systems, there are static analyzers. I don't think Go itself, you are not, it's not mandatory for Go itself, but a lot of static analyzers for Go will say, okay, there's an error here, but you're not capturing it, do something with it. So you see a lot, okay, call a function, do something with the error, otherwise do other stuff. So this is a very common system in Go. Also note there are no exceptions, so we don't throw stuff. For now, no, we don't throw stuff, so it's all passed by something like the error, like this way.
So what happens if you do a divide by 0 or something? You create your own error. What happens if there just is an error?
Then you can compile probably.
If it's a runtime errors, then it cannot detect them, so it will crash. But if it's compile errors, then it will notify you during compilation. So let's see if this works.
But you said if it's runtime, it cannot detect and it will crash, but the application, you just let it crash.
No, you can handle that.
Okay,
of course.
yeah.
You can handle that. In this case, it just panics because you cannot hello to moon. So it's in this part. If you're going to say sun, then it says hello sun. So this is basically how everything works. Call a function, process any errors, do whatever you want to do with it, etc., etc. Let's see. Okay.
Is there an order in the return types in the function hello?
Yeah.
You return string and error. Is this a rule to make an error last?
It's common to do it as the last element. So if you're returning 3 elements, the last one will be the error. That's just, it doesn't have to be, Go doesn't mind, but it's just everybody does it that way, basically. Of course, we have other stuff. So for instance, we can say for loops. So we define, in this case, an I is 1, and here we're going to use the semicolon until I not equal to 10, increase I, and we're gonna print the whole loop. So this will print it literally 10 times. There is no while in Go. So if you have a while loop, you have to do it with a for statement, which is probably the same thing. It's pretty much the same thing. So you can say for not done, and in this case done done bool as in bool. And we're going to say it's false, so we don't need to define it. So we can just do this. Okay, my system is too smart. Yeah, but this works the same way if you create the code for it. Okay, so one of the cool things is in PHP is that when you have arrays, you basically say something is an array, but you don't really define what's inside. It could be anything. It could be simple array with strings, could be integers, could be with string keys, could be integer keys, it could be objects, well not as keys, but you know. So there's all kinds of stuff. That doesn't work in a static type language, but we have something else than arrays, and that are slices. And to give you an example, I'm going to say planets is a slice of strings. And what is it? I'm going to assign it directly. I'm going to say it has the sun, it has Mercury, it has, what's next? Venus. Alright. Mars. Saturn? Well, I know it's there somewhere.
Jupiter, Saturn, I think.
Okay. You really care, apparently. Neptune and.
You're right. But Pluto's not, it's not a planet.
Yeah,
anymore.
And the sun is also.
If you're going to make a presentation,
No, the sun is a star.
that's fine, but in this case, Pluto is a planet.
Can you also remove string now? Because
Move string?
can you remove it and it still works? Or
Because we didn't define a length to it. So sometimes you can say, I want a slice of 5 strings,
yeah.
and then it's going to say, you know, Jupiter, get rid of it because it's too much.
And why would you do that? Because it makes your code much more difficult to adjust.
Memory.
For what?
Well, for the other programmers, they have to check, okay, it's a string of 5, and now we have to make it a string of 10.
I will show you in a bit. It has a reason. It has a reason. Okay. So we have planets. We can't. So what we can do is we can create a for range.
Well, this question was
Yeah.
if you can remove string.
Yeah, can you untype the array or slice?
No, because
So it doesn't automatically type it like it would with a normal variable.
no, you can't say slice. It needs to, it's the slice string. Oh, you mean this?
Okay. No. If you do it with a single string, then you don't have to type it, and it automatically assigns it, it seems.
No, the
It
slices
do
doesn't.
that. Okay.
At least not that I know of. Okay, so let's do for P in is range planets. Basically, it says range is iteration over all the planets in this case. And I'm going to say format print line planet. Now, this probably won't work because I get the keys and don't get the information. So if I want to do that, I can say key K and B, but if I don't want any indices, I can just say just ignore it. So you can do something like this. So now it will just print everything. So what I can do with this is, for instance, I can format print line, and I'm going to say length of planets. And I have a print s, it will say there are 10 elements in there. But a slice has two components. It has a length, so how many elements in there, but it also has a capacity, how much could there possibly be inside that slice. So I can do something like this, and you will see that in this case it's also 10, but if I do planets is append planets with planet X, famous last planet.
Night planet.
You see that the capacity is now 20, but if we actually look at the length, it's 11. So there's a capacity and there's a length. Normally you don't need to worry about it, but if you define something like this, 12, hopefully this works the way I intend to. No, because I only have
Or does it have to be 20 now, the capacity? Yeah.
oh yeah. No, this is not a slice. Okay, this is a bit tricky. No.
It's fixed length array. And
Yeah.
If you give it a size, it must have that size.
Yeah.
Nine
No,
elements.
it's not something I don't worry about it. I wanted to just demonstrate something else. Okay. Never mind that. Just know that there's something with the length and capacity, and both things are actually different. What I can do now as well is I can take partials of those slices as well. So I can say planets will be planets, but I want planet 1, so 0 place, 2, actually until index 3. So when I do this, it will say Mercury, so that's index 1, until index 3, but not including index 3. Could be very annoying, but it has benefits. So 1, 2, 3 means it's 1 and 2, but not 3. You can also say everything from the beginning until 3. So we'll get Sun, Mercury, Venus. Or I can say something like 3 until the end. And you get 3 until the end. You can also say this, basically everything from the start until the end. Has some use cases, but just know that this means the whole slice, basically. So that means everything. You can actually go further. If I say from planets from the beginning until 15, even though I don't have 15 in there, you see that it prints empty lines. This is because even though there are not enough elements in there, the capacity is bigger. So there is room for 15 elements. Even though they are not in there, there is room and they are not defined.
Instead of changing planets before doing the range, can you also do that in the range part? So,
Oh yeah, like
so instead of
this?
like, yeah.
I don't see why not. Cool. Okay. Yeah. So slices. What you will see sometimes is something like this. We're going to say planets. Define planets as a slice of strings, and I'm going to say planets is make a slice of string with 0 elements or with 10 elements. If you do this,
You have an accolade and a closing bracket. Yeah, planet.
sorry.
Dus een accolade en zo'n haakje bij de tweede regel.
Square bracket.
Ja, een square bracket.
Curly bracket.
bovenaan bij
Fine,
for.
for string.
Oh.
Here.
Oh.
Yeah, no, that's yeah, we don't make a string, we actually make a slice of strings.
Above in the declaration of the
Yeah.
variable, there's a curly bracket and a square bracket.
Yes, there.
It's a string.
Oh,
No, that's a string. Yeah.
Wow.
Seriously, that's
Square bracket.
that's the
Which
top
key
of the-
developers?
Oh yeah.
Oh, there's a dead pixel, yeah.
Because the editor
Yeah.
didn't mention it, so I was wondering why is that correct.
No, so we make a slice of 10 elements. They are all empty, and we add planet X after the rest, so that will be at element 11. So it's here. Slices is they're not that hard, but it's something you have to get used to. It's just a matter of working with it. Okay, so let's go to one of the hardest things, because this is a little bit editor dependent. We're going to create our own package, and I have to get back out of presentation mode for now. So we have that hello function, or we had that hello function like this. Now we want to create a nice package of it, so we can have a hello and we can have a goodbye and we can do all kind of stuff with it. So what I'm going to do is I'm going to create a directory called greeter, and then I'm going to make hello.grow, and notice that it now understands that I have a package named greeter, which is in the directory greeter. So that actually is correct right now. And I'm going to copy that function to the hello. Notice that errors is also an import. Now, the only problem here is that we have here is I get rid of this. The only problem we have now is that we are using packages and modules. And for this you have to actually initialize a module in Go. And it's something you have to do only once. I can actually do it here. So we have the our main directory, and there's a greeter directory in there. And I'm going to say go mod init. And I'm going to use github.com jdev clock AHV. Now, what it does is pretty much nothing more than create a go.mod file. It's sort of your composer.json file. It has dependencies in there, but it also defines what your Go version is that you want to use, and what your module name is. So in this case, this is your module name. A lot of times you're going to use where you deployed it as your module name. It doesn't have to be, but normally if you have a module called github.com /jdev/Eindhoven, it will probably be on that URL. So we use URLs for package names.
Can you translate packages and modules to PHP? I mean, help me understand packages and modules.
It's a bit, no, I will not. Not because I don't know it, but it can be a little bit complicated. Modules are not, well, they are a bit new, they're not.
Well, are you going to explain or not?
I explain why I don't explain.
Okay, that's fine.
Modules are a bit new, and there's a lot of old type of dependency code and new module code. But don't worry about that. If you do the go mod init, and you're going to set a setting which I will show you in a bit, then that's basically it. That's all you need to know for now. Okay?
No, I want to understand.
Yeah.
Go read the manual.
I will show you. Okay. So we have a main package, and now we're going to want to use the greeter. Now, one of the things we have to tell Go, at least the editor, is that we are going to use the modules, something like this. Now, if we can do, greeter. Dot hello, and we say world. We're going to print that. No, let's use format. Print line greeter. So we have something like this. So basically we say, okay, we're going to import a package called github.com/jtaf-talk-arv greeter. It knows we are in the module talk-arv, so it knows that we're going to use a directory in there. The package is inside the directory, inside the current directory. Now the only thing is, it can't find hello, and this is one of the things that people, I don't know if you're going to use Go, you will definitely going to yell at it more than once, because what you need to do is you need to export functions, and you export a function by using the first character of a function as a capital letter. So that hello shouldn't be hello, it should be hello. That's really annoying in the beginning. You will fail to understand why is it not working? I've done everything right. Oh, you didn't export it. Will happen. It still happens with me. Well, it doesn't say much, but it happens to everybody. So you have to export stuff, and you export stuff from a package by using a capital letter. This works for functions, but this also works for variables. So if we define a variable called greeter text is hello something, this is not exported, but now it is exported. I'm going to say it's like this. So now we have a greet text exported, so somebody else from outside the package, so our main package or somebody from the internet who has access to this package can actually use greet text and hello in this case.
Will it complain that the variable isn't used right now?
No, because it cannot know if it's in use or not.
So is it possible to make a variable start with a digit then? Probably not.
No. But it's a funny one to try. No. So if you go over here, now we can type hello, and now it understands hello. It actually understands, let's hope so.
Perhaps it's because it's already a function call with the brackets.
Ah,
I don't know.
that makes sense.
I've never really told it.
Greeter.
There's a red squiggly left in board.
Why is this? Why is this? You can build it. If you build it, it will tell you why, hopefully.
Perhaps you want to declare a type specifically.
Would help. No, I don't know. Not sure what I'm doing.
Semicolon?
No, it's about this one. We can check that.
Maybe you need to specify that it's a string when you
Yeah.
export it.
Because it's an
Problem.
module.
Delete it. Okay. So yeah.
You can take the short assignment. You cannot use the short assignment.
No. Yes, of course you cannot use it. So you have to do it like this. So this works, but this also works. So this is the same thing. Just say this is duplicate because it knows that the type can be omitted because you know it's already a string. So in this case you can't use column is, but you have to use default for that. Makes sense. Okay, so now we can use retext, but we want to use the hello planet Pluto. Nobody can tell me otherwise. Hello Pluto nil. Why is that? Oh yeah, it's because it also has the nil in here. So what we should do is we're going to say s and errors. Actually, I don't care about the errors in this case, so I just ignore the error like this, and I just say this. And now we can run Pluto in presentation mode. So this is basically packages. Now I've used a package that's inside my current directory, but I can also get a package that's on GitHub or anywhere else basically. Most of them you will find in Golang and on GitHub. So for instance, I have I have to make sure that I type it correctly. Capitalizer, and it's going to sync it. Yes, I just found it. And what I can do now is I can say capitalize, and you see automatically that there's an exported function called capitalize. What? Capitalize Pluto. So when I do this, and I run it, look, Pluto is very big now. Yay! You see, it's a planet.
Why does it specifically state capitalize in front of the import now?
Yeah, that's just annoying IDEs. So you don't need to do that.
No.
Oh no, in this case, no, in this case you probably don't need it because it knows that it actually uses the last name of the package as your namespace basically. But if it starts with go slash or go dash, then it will not use that. It's one of the things that are implicit. As said, there are a few things implicit, but not much. But this is one of those implicit things. But yeah, this is clearer basically. And we can use we can use Captain.
Oh, it's just an explicit name you give to the import your.
Yeah,
just
use
like
names
the PHP in namespace.
Because you can have a greeter, but you can also have another greeter from somebody else, and that will clash. So we can say else's greeter. So now it doesn't clash.
It's like use pack or as something.
And if I go to go.mod, you will actually see that it requires this module or this package from this version, date, and commit hash. So it automatically links to that. You can update them as well, but it's locked to this version in this case. And if you go to github.com, capitalizer, you will see that it basically is just one single Go file. So there's no packages you need to define or anything, just package capitalize with a function with a capital C, capitalize, and it does strings to upper of the as you're going to give it. Yeah, so it's really simple to create packages, to put them online so other people can use them straight away. Which is why there's a lot of packages in
Like NPM.
yeah, only this doesn't suck. Okay, let's go back to Hello. Yeah, we are on Hello. That's a copy. Okay, let's see. So we did packages. Let's talk about one of the main things, and that's structures. So PHP is obviously object oriented with classes and instances and a lot of people want to use private, but I really dislike private, but that's a whole lot of talk. Go doesn't have that. Go has structures, which is basically just a block of properties, block of data, and you can attach functions to that block of data. There is no such thing, there is, but not really, as extensions, but there is sort of interfaces, but not the way that you think interfaces work. So in PHP you define an interface with certain functions, and then when you say implements interface, you have to implement all that functions. In Go, Go says if a structure has functions that match an interface, it automatically implements that interface. So you don't need to specify this structure basically implements an interface. No, if it has that function or those functions you need, it automatically implements it. So for instance, what you can see a lot of times is that there is an encoder to JSON, for instance. So you want to have a structure exported to JSON. As long as it has a marshal function and an unmarshal function, it implements that interface. So everything that wants to use a JSON marshaller or a marshaller in itself can use that structure, because it's all automatically implemented basically.
By function names, so there are a lot of reserved names. Trying to grab this.
Okay. No worries. I will show you. That's why I have a computer here. So let's go back to the beginning and start with structures first. Okay. So a structure is something like this. I'm gonna say type program struct. No, struct program, sorry. And I'm gonna say, no, I'm gonna say person. Now it makes sense. With a first name, which is a string, a last name, which is a string, and an age, which is an integer. Now, if you're gonna format it, you can format it by the editor, but you can also format it on the command line by say go format, hello.go. Now I'm confused. Inline. I don't know who's done it now, if the formatter has done it or the IDE has done it, because it tries to be too small. Anyway, you can format it from the command line as well. So what you can see is that if you are in CI, the CI is going to check for the formatting, and if that doesn't match what it should be, then basically what PHP CS does, but it's built in Go itself. So now I have a structure of a person, and let's get rid of this. So we have to get rid of the import statements, which is automatically done. I'm going to say P is a person. I'm going to specify what kind of person. And if I want to do that, I'm going to say first name is Joshua, last name Thijssen, and age is, well, not 5, 42. No, I'm 43. I'm old. And it doesn't matter where you define it. So you can define it here, or you can define it here. It doesn't matter as long as you define it. Even if you don't define it, that's fine too. But that means that the age in this case is 0. So it's 0, empty string, false, nil, whatever is 0, nullable. That's what it is by default. So in this case, you would say age is 43. Now,
Can you make it nil?
like optional? In this case, no, because because you are an integer.
Can you also give like H2 declarations like you can do with,
So something like this.
yeah.
Yeah, no, because it's strict type. Otherwise, yes, you can do it. No, I'm not going to explain it, but try to be as strict as possible. There is something called interface, and you have something else as now. Interface. Interface is basically an interface without any functions. So anything automatically implements interface, because you don't need to implement anything for interface. So anything is an interface. A string is an interface, an int is an interface. So in this case, H is an interface. And basically you tell Go, you know what? Screw you, I'm gonna decide what is there. Don't mind this H thing. I will declare it, and if it crashes, it's on me, it's not on you. But don't do that. Interface basically means I have no idea what I'm doing.
It will be bad habit.
Yeah, but it has its use cases. But let's just use hints for now. Okay, so we have an H, so we have a person. What we can do is we can print that information with this thing, and I'm going to say print P. Let's see what it does. And then it's going to print like debug information. Sometimes you want to do that, but yeah.
I'm from a C# guy, so struct for me is a value type, and class is a reference type. Does Go have that difference, or?
Yes, you could create a pointer to it. That has use cases, but for instance, you can return, if you have a function that returns a structure, but sometimes you don't want to return a structure because of an error, then you can use a pointer reference to that, so it can return nil in that case. So then the structure will be nil, the error will be filled, things like that. But again, that's
Stuff just automatically explored because it's not capitalized.
it's not capitalized, so it's not exported.
Is a person also like an interface?
No, person is not an interface.
Because my initial question, you were that was what was it again? With interfaces, it automatically adds an interface instead. I come from a PHP background,
Yeah.
so I have zero knowledge of Go. So I declare an interface and I explicitly have to implement it. And you said it is automatically, well, the main interface you mean, or an interface you define yourself? Still grasping.
Okay, let's go step by step. This is the first step. We define the structure.
Okay.
It doesn't have any function to it. So what we can do is we can create a function to define to detect if somebody is an adult or not. So what I can do, in this case, we have a function, but now we're going to attach that function to the structure, and we do it something like this. With P, and we're going to say person. I did too much. Hang on. P person, like this. And we're going to say is adult, and that will return a boolean. So what it does now, it is a function. It's not an object or something. It's a function that gets called with a person structure. So in this case, I'm going to say return person age is 18 or above. So now imagine there's an interface called adultable. And that interface says, okay, you have to define a function is adult. If that was somewhere defined, then this structure implements adultable without me telling it that it's adultable. So it's basically, you don't have to say to a class implements something. the fact that you implement it is already good enough for Go to notice that that interface is implemented.
But what's the use case then? Can you use the fact that it is implemented somewhere?
Yeah.
So you can,
So,
so you connect, yeah, it's kind of like JavaScript. You can just go to the prototype and connect something to something else which isn't within the structure.
I
So you can
don't
just-
know
Oh,
JavaScript.
okay.
It's
It's
pretty
just-
much the same.
Yeah, prototyping.
Okay, if you say so, I have.
I recognize the patterns.
Okay. So, yeah, in this case, I can do format. Then if, no, I can say if P is an adult, then print we are adults. Otherwise,
No beer for you.
try it. Like this. This works, obviously, and if we are 17, then already. So basically, everything that is a person can use the is adult class. So we define in this case literally a person, but we can do it also different ways. This is basically this is not a constructor or something, but you have like new functions that generates structures for you. So what you can do, for instance, is say we have a function new person that's going to have a first name, last name, both are string, and it's going to have an age, which is an integer, and it will output. Oh, we can say it output pointer to, no, that's not complicating things too much. And it outputs a person. So in this case, we do the same thing as we do here. We're going to say E is a person, first name is F, last name is L, and H is the H. And we're going to return P. It probably will say, yeah, you can make that easier by just returning this. Let's not do that. And now we're going to say P is new person, John Doe 19. It's going to say you can't export it, but that's not a problem per se for now. Yeah, it's not a problem per se for now. So this is something you see very common. So you have a package, and a package has a structure, and that package has a new function. Sometimes you have multiple new functions, and then you see new person or whatever. But if you have a person package, you probably have a function called new, and if the function name is new, then it implies that the package name, in this case person, is the structure that you are doing. So both are different ways on generating stuff, but in this case you can actually say, okay, we have to validate first name, last name, and stuff like that.
Can you also attach a function to multiple structs? For example, if you also have an animal struct, then you would also want to check if it's is that
Yes,
possible?
but not in this way. So there is like an object-oriented aspect of it by extending stuff and such, but not in the PHP/OP way that you are used to. It's a little bit more complicated, but it's also something that you don't use very often. Okay, so one of the cool things now is that what we can do is, we talked about JSON, so we can say JSON encoder, JSON Marshall indent, and because JSON is one of those packages that automatically it knows it has a standard library of packages, so JSON is in there as well, so it knows it straight away. I'm going to say it says any here, any is the same thing as an interface, so it just whatever it is, I don't care, just fine by me. So I'm going to say P, the person, and then I'm going to give a prefix of nothing and an indentation of 2 strings, or 2 spaces. And what's it going to do is make B, that's a slice of bytes. Bytes is something else than a string. Bytes is basically an 8-bit thing. So if you work with data files, then you are working with bytes. If you're going to do things like reading from websites or stuff, you get bytes. You don't get strings, but you get bytes, but you can convert them to strings. But you get bytes in this case, and you get an optional error. So first thing we need to do is, if error not equal to nil, then log panic something is wrong. Not nil. And otherwise we can just do something with the bytes. So what we can do is format print line the bytes, but bytes is not a string. So what we can do is, this probably don't work, we'll see. Yeah, it does work, but it prints literally the bytes, 2 bytes. This is, if we do it this way, we can actually cast it to string. Bytes can be casted to string because it has an interface that allows it in this case. Then we're going to see an empty JSON error. And why is it empty? Any idea?
The structure doesn't have
Because all the properties in the structure are not exported. So if we capitalize it, yeah, oh, you're gonna hate Go. If this will happen. This will happen.
Why you just see a glorified constructor and that structure that might be.
Yeah, don't see it. Yeah, it's very easy in the beginning to map it to PHP type of things, but that's you will get. No, don't.
If you wonder why there are too many Go projects with 100,000 lines of code or more, this is probably one of the reasons. You have to change everything every time you have to export something.
Yeah, but that also depends on how you do things, because like there are projects of 100,000 lines of. But yeah, I the way you get.
It has been asked before, I think, but why can't you make person capital P and the rest lowercase, and then
No.
That's not.
This just means that the person structure cannot be used outside of this package. So it's basically protected.
Okay.
But if you want to export it, you need to make a capital.
Yeah. And then everything else has to be capitalized as well.
So the error is a special type because you imported errors, so I expect it to be.
It's not a type, it's also a structure.
But there's no letter, not capitalized, is it? In the or was it greetings go file or not? Or am I mistaken? So yeah,
No, you said yes, yes and no. You probably talked. Let me see if I can get it. This creates an error.
It's creates a new error, but you returned a string and an error.
Yeah.
And what's that type? What's
Yeah.
the error type?
That is probably that's an interface
Okay.
with a function called error.
Okay.
So it's not a type.
No, it's an interface.
Yeah, those things can be tricky. Where are my? Help? I want to go back.
Probably you need to exit again.
Okay, I'm completely messing this up. Go away, go away, go away, go away, go away. And presentation mode. Okay, so we have at least we have data, right? Because if we're gonna run it, oh, errors already. Compile. Okay, One of the things you will see often is you can actually add metadata to it. And you're going to say, JSON, I don't want it to be called first name, but first underscore name. And in this case, if you run it, it actually changes it. You can also say, listen, I want to have it exported, but I don't want it to be inside the JSON files. You can actually use a dash for that, and then it gets rid of it. If your name, if you don't have a last name, it will show it, but if you're going to say JSON last name omit empty, it will actually say, okay, if it's not there, I just don't show it, and if it's there,
It's not quite intuitive, but there's extended documentation about how these things work. This is, for example, for JSON, but probably also for other packages.
yeah, and you can have your own custom as well.
Yeah.
Yeah.
Oh, and just to recap, uppercasing the, what do you call it in the struct? Not the properties. Are those properties? Fields, yeah. It's sort of like from a PHP perspective, making them public properties or something. Just from private to public. You can just make one private again by making it lowercase.
Yeah.
Okay.
Yeah, there are ways to create getters and setters as well.
Okay, that is scope now.
Yeah. Okay. Well, the only thing that we can do is something like IOUtil, which has got file writers. You can say write file blah JSON, and it wants data. That's going to be the B. That's our data, and it's going to be read write for us, read for everybody else. Oh, you see, please handle the error. And you say, all right, I'll handle the error. No. Fine. Oh, you see here that it has an issue because we're gonna declare and assign error, but we already did it here, so you can't do it here anymore. So it has to be. It's again very annoying because if you're gonna remove this, then it's gonna. I don't know what the error is. Oh, yeah, I have to change it here again. So this is especially with sometimes coding, debugging, you get sometimes stuff like that.
Yeah, so you just overwrite old.
Yeah,
That's
some
okay.
people just define add error
Yeah.
on top and get rid of it.
You have to call it error.
No.
You can also context specific error naming things.
Ja, als je dit wil doen.
Yeah, I was thinking about that, yeah.
Fine.
I have to be clear.
Your
But,
feeling.
Misschien cool.
So yeah, you can do this.
read my mind.
And then it most likely created a blah.json which has got data.
Who does a cat?
Okay.
Sorry.
Is this clear? Because these are pretty much the foundations of Go actually. Yeah.
Small question. So if on line 32 I would say something var x equals p, then I have a copy of p or a reference to p.
In this case, you have a copy.
If I change the age of x, then p would still remain the same age.
Let's find out. So x age, because it's exported, we can do that. 17.
That's what we object-oriented people want to know. Yeah. By references, by value.
It's like
It's the only question.
language.
Yeah.
So it should be 19. What you can do, you can say, I want to have a pointer to that, and I'm going to say, create a reference to it. And then I have no idea what this is going to do. So don't confuse this with the same thing as in PHP, because PHP references is messy at best. But yeah, you can do references this way. Sometimes it's useful, sometimes it doesn't matter, because it's all compiled and optimized internally anyway. So you don't always have the benefits that you think you have or the drawbacks that you think you have. It's very Go specific. Okay, there are, well, a few things that I can do. So I have a bit of examples for setting up an HTTP server, so you can create an API. I have a bit of Go routines. Go routines basically is one single program having, well, not multiple threads, but something that looks like multiple threads doing a lot of stuff simultaneously, which is really cool. It's something that's pretty specific to Go. And I have some benchmarking and testing with PHP. No, not PHP, with Go. I can do PHP as well, but that's neat. So, depends on what you guys want.
Testing, please.
Testing, please.
No, not testing.
This is
Number 2.
What's the most difficult one?
The process.
Yeah, the Go routines is really nice.
Yeah.
Okay.
I didn't force you there, right?
No, you didn't.
It's on camera now. I didn't force anyone. Okay, Go routines. So Go routines are basically functions that are simultaneously run. So you can have a function like in this case an hello world that prints hello world, and you can have 10 of those functions running at the same time. Would be very stupid because that's not something that you will do async. But for instance, if you have something that like a web scraper, when you have 10,000 URLs and you're going to scrape them, you can have like 100 workers in the same program, all getting one URL, scraping, and 100 times simultaneously, which means, you know, instead of doing things serialized one by one, you can actually do a whole lot at the same time. This is basically doing async stuff, which can be very complicated, but it's pretty decent setup in Go, with the help of something called channels. And channels is basically a way to communicate between different threads running at the same time between different functions. And I can give you an example. So let's get rid of everything except our main function from the main. Let's see what I had. Okay, so this is basically a function that gonna sleep for a certain duration and get element. Okay, so what I do is I have a function that has let's say I have 1,000 numbers and I want to do something with that number. And it doesn't matter what it is, it could be a wrong calculation, it could be a web scrape or anything, but I just mimic it by doing a simple sleep. So what I normally could do is something like load numbers into a slice. For number is in range of that slice, do stuff. So you can do something like this, right? But this is serialized. So if that slice is 10,000 numbers, this is going to be 1, 2, 3. Okay. So what we can do is we're going to say, okay, we have like 10 workers that all waiting for an input. And once it receives the input, it does something with it. It can output stuff, but it doesn't have to. In this case, we don't, because that makes it a little bit more complex. So it will just do some stuff with it. And the program waits until everything is done. So to do that, we're going to use channels. And a channel is pretty much exactly what it says. It's one way where you get data in, and on the other side, you get data out. So is it a queue? No, it's a channel. Can't make anything else of it. So what we're gonna do is we're gonna say, I have to do this by my notes. We're gonna define a channel of integers. So just say CH, which is the common name for a channel, is a channel where we store integers and where you can read integers. What we need to do is we're gonna make a channel of integers. So what we saw with a slice, where you define something, where you create something, this doesn't create anything, this just defines that, okay, CH is probably a channel of integers, but doesn't really declare it. But this actually makes it. So there's now a channel with integers. Now, what I'm going to do now is I'm going to create 10 workers, and that workers do a certain function. Now, in order to make something threaded or async, you're going to use the go keyword for it. So we're going to create a function. You can do it multiple ways, so we can create, now, we're going to say go worker. Worker is not defined, so we're going to say worker here. And that worker does stuff. Now the thing is, it doesn't call that worker directly, it just calls it in a new thread, and it will return immediately, and then in the loop it will call 10 workers. In this case, workers doesn't do anything, so they exit immediately, but they can do all kinds of stuff. So what does the worker do? Actually nothing for now. Let's not do that. What we're going to do is we're going to create another 10,000. Now let's start with 1,000. We create a loop of 10,000, and we're going to say the channel that we created, and this is one of the few real symbolic things that we have, is something like this. Yeah, no, not crypto round. Well, yeah, no, use not. Okay, so what this does is basically it says get a random integer and put it on the channel. That's it. That's the only thing that this does. Only does it 1,000 times. And at the end, you do it a different way normally in a normal program, but for now I'm going to say I'm going to sleep 100 seconds. This is just waiting. Now, so the only thing we need to do is the worker, 10 of those that are started, we need to do something with them.
And when the go is launch a new worker instance, or start the work function.
Yeah, so it starts a new go thread basically,
Okay.
and that go thread calls the worker function.
Yeah.
If the function is done, does it immediately kill the go thread, or do you have to deal with it?
Yeah, no. It just removes it if it's. It also takes care of deadlocks and everything, so it will notify you that it's. Normally, you don't really have to worry about that too much. Okay, so that worker, what we want to do is we want to do an endless loop. So the worker just keeps on working. So the for without any conditions in it is just while true off. So it keeps on going, and what does it do? Well, what it wants to do is it wants to get something from the channel, and you have to do it like this. So what I'm going to say here, in this case I have to make channel a little bit global, otherwise it doesn't understand it. Well, we could add it here. That's nice, so let's do that. So we have a channel, and then we're going to give the channel to the worker. That makes more sense. So I have an I and OK. If you get something from a channel, it blocks until something is on the channel, and when something is on the channel, it will store it in I, and if something happens with the channel because it's closed, for instance, then OK will not be nil. So with the OK variable, we can actually check if something is going on with the channel. So this way you can also notify workers that we're done. So there's no need to do anything. We can stop now and get the rest going. So that's okay. And what I'm going to do is I'm going to sleep a certain duration. Time duration want an integer between 0 and 100. And that's in time and milliseconds. Do I have this correct? No. Yes. Okay, so it sleeps between 1 and 100 milliseconds every time something gets on the channel. That's basically our work, whatever it is. Once done, it will, what we can do here first is, if not okay, then we can break the loop. And it will automatically close because the function returns, so the code thread will get killed.
If it's not okay or if it's okay?
The channel is not ready.
Yeah, if it's not okay. So if it's not okay, so the
What gets stored? What you talked about it this earlier. What
Yeah,
gets stored in okay?
okay.
The Boolean data type or
Second return.
Yeah. The I is the integer and okay is
yeah. So if it's true,
okay. It's
then
Boolean.
nothing is wrong with the channel.
Okay.
If it's false, then something is wrong with
Okay.
the channel.
Yeah.
Okay, so afterwards, when we have done our work, we're going to print thread something just received a number. Channel index, I don't have it yet, but bear with me, and I. Channel index is something we get from the function as well. That's an, that's an integer. That means we have to get the channel index here. So every worker gets its own ID, so we can differentiate between them. So depending on which worker, no, we don't call it thread, we call it a worker in this case. That's it. And when it's done, so okay is not true, so something happened. Probably the channel is closed. Then at the end we're going to say printf worker something is finishing up, and that's channel index. So we have something like this. Printf, sorry. There's one thing I need to do. Yep, there's one thing I need to do. So what we've done now is we created a channel. We spawned 10 workers on it. And then the workers do nothing until something goes on the channel. We have 1,000 elements on the channel, but before we're going to sleep, we are going to close the channel. So after the 1,000 items are on the channel closes. So after the last element is taken from whatever worker puts it on, the next time it's going to look, it's going to see that the channel is closed at that point. Is this understandable?
Yeah, but check if I understand. The channel is a sort of globally scoped thingy where the workers can get data from. So
Yeah.
That's not from a program perspective. It's not a global variable or something. It's a process or a worker of a thread, but it's something global. The worker because it's given by
Yeah, it's a way for different threads to communicate with each other. This is basically the only way how we should communicate with threads.
So it's basically a queue.
Yeah,
But
they
is
call
it-
it channels.
With
implicit
with
or
instance, but
Sorry?
or a bus.
Yeah.
Is it also artificially working as a queue, or if you don't put a sleep in there and you have 10 workers, will they all print out the same thing?
No, everybody will get, if something is taken from the queue, then nobody else can take it.
Okay.
I hope.
You know, always some CPU tech.
No, you'll be fine. Okay, let's see if I did everything correct. Probably not. Main collides with. Yeah, I don't care. Let's see. Oh, there we go. So we get random numbers, and all the different workers just pick them up. And at the end, Q9 is finishing up while worker 8 still receives something, and all the way down until everybody is finished up. And that's done. So now we have just the whole thing parallelized.
Can you remove the sleep and then do it again? I'm just literally wondering what happens.
See how fast your laptop is.
See if it produces snow.
Done.
Okay.
Yeah.
Fully pointed.
So we can make 100 parallel items, makes it much faster.
Yeah, but it's only taking one issue at a time, one integer at a time. So
One integer, but it doesn't have to be integers. It could be a structure as well.
Of an API call, probably.
Yeah. So instead of an integer, you use a string. That's a URL, and the worker will just scrape that URL, which is something I use a lot. That this common setup for stuff like that. Yeah.
Pretty amazing for such few lines of code.
Is it also
Damn amazing.
is it also multi-core, or is it?
Yeah. No. This is the thing. These are not real threads, as in operating system threads. These are Go threads, and Go threads is basically there's a threading mechanism in Go that deals with everything, but that doesn't mean it's the same as an OS thread. That also means that Go threads are much faster as operating system threads, which by itself are already faster than operating processors. But it's up to Go, your binary, to actually say, okay, listen, I put this on this core, and this on this core, and this on this core. You can a little bit force it. So what you can do is you can say, okay, listen, obviously if I have 100 threads, they won't all go to a different core because I have only 8 of them, I think. But you can actually ask Go, how many cores do I have, and use that as the number for
the workers.
For the workers. But it doesn't 100% mean that every Go worker will be on a single thread. Probably it will, but it's up to Go to decide that ultimately.
Is there a sweet spot in the number of Go routines?
Yes, it's called benchmarking. And it's different for every application and whatever you do. So you don't want to saturate all your cores, obviously.
No, there's not like you have like 4 cores, use like 16 of them or something.
No,
Just whatever. It is.
because if you do like calculations, it's probably much more intensive for the cores than doing web scraping, which just waits on I/O.
Yeah.
There are only 100 things to wait on I/O instead of just one serialized. So it really depends on your. But yeah, this is a pretty simple way to make things really, really fast, especially when you do things like this. Is also the way how you use like web servers. So there's a web server, you can say, okay, I'm going to listen for ports, and every time there's a connection coming into that port, I'm going to fire up a worker, do the stuff, and when it's finished, then it's going to kill that thread or that Go routine, and then we're done with it. So it's fast, it's memory efficient, and it's not a lot of code that you have to do, which is really awesome.
And quite readable too.
Yeah, sometimes it doesn't, because this doesn't really make a lot of sense in my opinion, because maybe you want just a number here, but sleep needs a duration, and the duration is not a number, that's a duration, is actually a type. So I just say make a number into a duration and then multiply it, in this case with millisecond, or just with second. So I don't have to care about how many thousands is this, and just say no, okay, I just want to do
Yeah, I think it's quite.
millisecond. It's readable.
Yeah.
Yeah.
Syntactically, you have to read the manual, of course, but this is quite clear. If it said 10,000, for other languages, is it in seconds? Is it in milliseconds? It can differ, but
Yeah. So
it's quite explicit.
one of the few things that looks tricky, in my opinion, if I would start with Go, and when I started with Go was just this and this, because this doesn't really. Maybe it would be nicer to have something like this sent instead, which actually you can create, but you don't see it very often.
So just wondering, now you create the workers and a channel at the same time, right? But can you also create a worker based upon if the channel sends a message? So if the channel gets a message broadcasted over it, can you then create a worker to immediately process it and all?
That's basically how those web servers work.
Okay.
So there's a single point of entry that just waits for a channel or and something else puts an incoming request on the channel, and then that system just says, okay, I have a request, just go to that
Fire up a worker, go.
and it waits until the next request.
Like the generic HTTP client probably will also create a Go routine for each call it does.
Most likely.
Yeah, you just use it, but
Yeah.
most likely you won't.
And then you can make a second channel to communicate back from the worker function or worker
Yeah,
routine.
in this case, we have like a channel where we do fire and forget, so we just pump in data, but you can have another channel to get information back, but that's a little bit more complicated because you need to know what's what, because you need to have, you can have a single return channel, but you need to identify which worker is it, which data is it, probably. But you can do whatever you want. You can create 10 different channels. So often you see a DOM channel as well. So we have a DOM channel that's always empty. It's a Boolean channel, and the only thing that it does is as soon as things are done, it sets true on that DOM channel, and then everything that looks at that DOM channel knows, oh, okay, we're done, so we have to clean up and get rid of everything. So that's something you see. We use the close function here, so we're going to use that, okay. But often you see also like a DOM channel, which is a channel Boolean, and then we're going to wait for either something in the DOM channel or something in the CH channel, depending on what it does its stuff. So there's all kinds of, you can go wild with stuff like this. Yes.
What I find really nice is that you can give a channel a fixed size, so that, for instance, if you have a fixed number of workers, the receiving end is putting things into the channel until it's full, and then it just blocks, waiting until there is room in the channel, and that's a really nice pattern to create a buffer.
Normally a channel is just for one element, but you can also say, okay, I want the channel to have 1,000 elements. In this case it doesn't matter, but you have cases where you want stuff like that as well. Yeah. There's all kinds of neat tricks you can do with those channels. But keep in mind, this is async stuff, which is sometimes hard to get your head around to see, okay, when is what doing what. But yeah, if you keep it simple like this, then
It's hard to debug.
yes and no. We can actually debug quite easily if I have to get rid of this. So I'm just in the worker and I get my integer, okay, is true. So you see here is one worker, and there's a lot of workers here.
It's like XP good.
Yeah, only this works out of the box.
Yeah.
Yeah.
Is there also asynchronous? Is there also syntactical sugar? You have to write it yourself, like promises or something, where you can procedurally write because the promise and then finally things. Or people have made those libraries?
I hope not.
Oh, why not? I rarely use them, but I see use case for them.
This is also why I have a serious dislike for JavaScript. Is like, okay, you're a single-threaded language, act like it, and don't pretend you're async, and don't make up excuses. Oh, but we have promises, and we have await, and we have this, and we have that. I maybe I'm too stupid to understand JavaScript. It probably is, but I really don't like that way of working. I bet if you're gonna look on the internet, there probably is promises in Go. But to be honest,
it's not a native function.
no, I don't see the point in that. To be honest,
That's syntactical sugar, but it's nothing more.
yeah, you have something called weight groups where you can actually
Waiting rooms.
weight groups.
Yeah.
Where you can actually tell the system, okay, I have 10 workers or 1 worker, just wait until it's finished and then continue with whatever I do. So it's, yeah, maybe you can fiddle around with that and create something like that, but to be honest, it's there are better uses of your time, I think, if you do something like that. That's pretty much not the way how Go does. It's like Go reads and
Okay, but you use the time sleep 100. Why is that? Because the program terminates otherwise before the workers are done? Or?
yes,
Okay.
yeah. When the main thread finishes,
Yeah.
then all other threads will be killed as well.
So if you remove the time sleep 100 function,
Yeah.
then we won't see any output.
Not a lot.
Not a lot.
Maybe some, but not a lot.
But can't you check then on if there's still a channel available?
Yeah, but if the channel is empty, doesn't mean the workers are ready. This is where wait groups come in. So we have a wait group that actually says, okay, I'm ready. Me as a worker is finished. Now you can continue with closing down the program, for instance. You have a question?
I was about to ask if monitoring is possible, but I guess that's handled by those wait groups.
Sorry?
I was about to ask if monitoring is possible. Like monitoring workers.
From an external point
From the main function point.
Yes and no. Actually, this is also done with channels basically. So we probably have a monitoring channel where the worker deploys information like I'm busy with something or so you can do something like that. Pretty much all communication between workers and other workers or the main process is done with channels. So yeah, you can do it. Yeah, I don't know if I've seen it very often, but yeah.
But the same goes for logging then, because the I/O can kill the system.
Yeah.
I can assume that your I/O will block due to your file system being locked at some point.
Yeah, well, if all workers are logging in the same file, then
Yeah, mostly it is, right? So it's
it probably is locked, but I'm not 100% sure.
yeah. Okay.
They are one of the most common log clients of packages is Logplus, and that's probably takes care of that. It's a
I'm sure, yeah.
very flexible package, but I'm not sure how the
Internals work, yeah.
It's async. It can do everything. It's
Yeah, but that's probably the reason, right? Because this guy, I think it's the most common issue we see.
well, create a log channel and have one single process do the logging. Then you're done.
Yeah, fair enough.